This is SpaceTime Series 27, Episode 152, for broadcast on the 18th of December 2024. Coming up on SpaceTime, how those infamous Martian dust storms end up engulfing an entire planet, astronomers discover another population of dark comets, and a new study of the effects of space weather events are showing how they impact our national security assets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has begun to unravel the mystery of those massive planet-wide dust storms which often blanket the entire Martian surface. The new data suggests a key trigger for these global storms could be relatively warm and sunny days on the red planet. The new findings, reported to the 2024 meeting of the American Geophysical Union in Washington, could be the first step towards forecasting extreme weather events on Mars, just as meteorologists do here on Earth. Martian dust storms, full of swirling, light-obscuring grit, can have a significant effect on rovers and landers on the red planet. They clog up scientific and other instruments and block out light to solar panels used to power equipment. The study's lead author, Shani Perez from the University of Colorado Boulder, says Martian dust storms consist of very fine light particles, but they stick to everything. The new findings allowed Perez and colleagues to identify weather patterns that may underlie roughly two-thirds of the major dust storms we see on the red planet. Dust storms on Mars are something to behold. Many begin as smaller storms swirling around the ice caps at the planet's north and south poles, usually during the second half of the Martian year. Now, it's worth pointing out that a Martian year lasts approximately 687 Earth days. But these dust storms can grow at a ferocious pace, quickly pressing towards the equator till they cover millions of square kilometres, lasting for days if not weeks. Now, you may recall the 2015 film The Martian. It featured one such apocalyptic storm knocking over a satellite dish and tossing around astronauts. Now, that's Hollywood. In reality, it's far less dramatic. See, the Martian atmosphere is much thinner than that of the Earth, just 1/99th of Earth's atmospheric density. So dust storms on the red planet simply can't generate that much force. But they can still mean trouble. In 2018, for example, a global dust storm buried the solar panels on NASA's Opportunity rover, covering them in a thick layer of dust. Without sunlight able to reach the panels, the rover died. And exactly the same thing happened more recently to the Mars InSight lander. In the current study, Perez and colleagues set their sights on two weather patterns that tend to occur every Martian year, known as A and C storms. The authors examined some 15 Earth years of observations from NASA's Mars Reconnaissance Orbiter over 8 Martian years. They looked for periods of unusual warmth, weeks when more sunlight filtered through Mars's thin atmosphere and baked the planet's surface. They discovered that roughly 68% of all major storms on the red planet were preceded by a sharp rise in temperatures on the surface. In other words, the planet heated up, then a few weeks later, conditions got really dusty. Now, of course, we see very similar phenomenon triggering storms here on Earth. During hot summer days, warm air near the ground can rise through the atmosphere. See, when you heat up the surface, the layer of atmosphere right above it becomes buoyant, and that causes it to rise, dragging dust up with it. The authors are now gathering observations from more recent years on Mars in order to continue to explore these explosive weather patterns. Eventually, they hope to get to the point where they can look at live data coming from the red planet and actually predict what's going to happen weeks in advance. This is SpaceTime. Still to come, astronomers discover more dark comets and how national security assets are being affected by space weather events. All that and more still to come on SpaceTime. The first dark comet, a celestial object that looks like an asteroid but moves through space like a comet, was only discovered 2 years ago. But soon after, another 6 were found. Now, astronomers have detected 7 more, doubling the number of known dark comets. The new discoveries, reported in the journal The Proceedings of the National Academy of Sciences, have allowed astronomers to place these dark comets into 2 specific categories. larger ones that reside in the outer solar system and smaller ones that reside in the inner solar system. Astronomers got their first inkling that dark comets exist when they noted in a March 2016 study that the trajectory of the asteroid 2003 RM had moved ever so slightly from its expected orbit. And the thing is, this deviation couldn't be simply explained by typical accelerations on asteroids, things like the Yarkovsky effect. That's caused by a buildup of heat on the sun-facing side of an object, which, as the object rotates, then radiates that heat back out into space on the night side of the object, in the process producing a small amount of thrust that can cause the object to deviate from its original course. But the type of deviation observed in asteroid 2003 RM was far greater than this, and usually means it's a comet, with volatile material outgassing from its surface, providing the thrust. The trouble is, there were no visible signs of a coma or cometary tail. Then in 2017, astronomers discovered history's first documented interstellar celestial visitor, U1 Oumuamua, a strange cigar-shaped body that originated from beyond our solar system. Not only did it appear as a single point of light like an asteroid, but its trajectory changed as if it were outgassing volatile material from its surface like a comet. And the fact that this first object we discovered from interstellar space was exhibiting similar behaviours to 2003 RM made 2003 RM even more intriguing. By 2023, astronomers had identified 7 solar system objects that looked like asteroids but acted like comets. And that was enough for the astronomical community to bestow upon them their own celestial object category, and consequently they became known as dark comets. Now, with the finding of 7 more of these objects, astronomers can start asking a new set of questions. The study's lead author, Darryl Sligman from Michigan State University, says he now has enough dark comet examples to begin asking if there's anything that could differentiate between them. By analysing both their orbits and their reflectivity or albedo, the authors were able to find that the solar system actually consists of 2 different types of dark comets. One kind, which they call outer solar system dark comets, have similar characteristics to Jupiter family comets. They have highly eccentric or elliptical orbits and are usually on the larger side, hundreds of meters or more across. The second group, or inner dark comets, tend to reside in the inner solar system, hanging around the terrestrial worlds of Mercury, Venus, Earth and Mars. They travel in nearly circular orbits and are generally smaller, usually just tens of meters or less in size. These new findings not only expand science's knowledge of dark comets, but also raise several questions, such as where do they originate from, what causes their anomalous acceleration, and could they contain ice like other comets? Sligman points out that dark comets could have been a potential new source for having delivered materials to the Earth such as water, necessary for life as we know it. So, the more scientists can learn about these dark comets, the better they can understand their role in our own planet's origins. This is SpaceTime. Still to come, how space weather events affect national security assets, and later in the science report, scientists move a step closer to replacing lithium-ion batteries with new rechargeable proton batteries. All that and more still to come on SpaceTime. Scientists are working on new research projects to help protect major national security assets from the threat of space weather. In the past, these geomagnetic storms triggered by the Sun's 11-year solar cycle weren't considered a serious national security problem. But as technology becomes more sophisticated and as it occupies more of the ultimate high ground in orbit around the planet, space weather is becoming a serious issue. These geomagnetic storms are really a double-edged sword. They're capable of delivering spectacular, majestic phenomena like the aurora borealis and aurora australis, the northern and southern lights. But they also cause all sorts of electromagnetic issues here on Earth and in the near-space environment around us. They can damage or destroy satellites by short-circuiting their delicate equipment. They cause communications and navigation blackouts, affect terrestrial power grids by overloading electricity lines, shorten spacecraft lifespans by causing the atmosphere to expand, thereby increasing the amount of atmospheric drag a spacecraft has to endure, resulting in orbital decay and forcing that spacecraft to use up more fuel in order to maintain an operational altitude. And they can affect the safety of astronauts in orbit by increasing their radiation dosage. And it's not just up in space. In 2014, researchers with the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, discovered that plasma bubbles connected to space weather events partially contributed to communications outages during a major battle in the Afghanistan war. And that resulted in 3 US Navy SEALs being killed. That incident triggered Johns Hopkins researchers to work on new applications, such as atmospheric models and new sensors and instruments, which not only aid in discovering anomalies being caused by space weather events, but also to investigate how to keep critical national security assets safe, both in space and on the ground. Johns Hopkins researcher Ben Esposito says society has a huge dependence on space activities now. Most people don't realize how much their daily lives relies on what's happening in space. He says a powerful solar flare or coronal mass ejection, where plasma bursting away from the sun into space and possibly towards the Earth, can potentially erupt power grids, affect railroads, disrupt navigation, radar and communication systems, damage satellites, and harm astronauts operating in space. For example, space weather can cause ionospheric scintillation, a phenomenon during which subtle changes in the ionosphere alter how radio waves travel. In some scenarios, these radio signals sent at an appropriate frequency typically bounce off the ionosphere. But when space weather events occur, these signals can bounce in unexpected directions, or they can escape through the ionosphere completely. Now, if you're broadcasting on the ground through a disturbed ionosphere, other spacecraft may end up receiving signals which you're trying to send securely. And strong space weather events can adversely affect not just one system, but a combination of different systems. And when that happens, others can take advantage of critical systems and networks. So, the ability to forecast these dynamics and the potential impacts of space weather phenomena in near real time is critical. The NASA Center for Geospace Storms was established in 2020. Its aim is to develop a holistic predictive space weather simulation designed to estimate how a specific geomagnetic storm is likely to impact the Earth. And in April, the Centre made its new model available through simulations. Johns Hopkins researchers are now using these simulations to help them understand how space weather affects the near-Earth environment, uncovering when disruptions in the upper atmosphere might happen, and then monitor changes in the atmosphere and how that's affecting satellites. This report on space weather from the Johns Hopkins Applied Physics Laboratory.
Welcome to the heart of our solar system, our sun. Beneath its wonder and life-giving beauty lies a potential for peril. Approximately every 11 years, the sun's magnetic field undergoes significant shifts, causing heightened levels of solar activity. During this period, the sun unleashes a greater number of more intense solar eruptions, each potentially carrying the equivalent energy of over 10,000 Category 5 hurricanes. These eruptions occur in random directions, and at the peak of solar activity can happen daily. Yet, despite their frequency and size, the Earth is merely a speck in the vastness of space. Are we prepared for a catastrophic solar storm? The dangers of a solar eruption come in 3 phases. The initial flares composed of photons and X-rays hurling through space at the speed of light. 8 minutes after eruption, we detect and experience the effects of the flare simultaneously and without warning. Minutes to hours later, a stream of high-speed solar energetic particles, or SEPs, impacts geospace, creating a radiation risk to astronauts and posing a threat to certain spacecraft components. This is followed by the biggest punch, as the coronal mass ejection, or CME, hurls billions of tons of charged particles into space at millions of miles per hour. After eruption, these elements speed through millions of miles of nothing in a sea of silence until they reach the first Sun-Earth Lagrange point, where our only upstream sentinel lies. Astronauts at or en route to the moon have to take precautions against the SEP radiation, while those in transit through the Earth's radiation belt may need to prepare for enhanced particle intensities. The CME then collides with Earth's magnetosphere, where it interacts with the planet's magnetic field and the everyday technology that resides within it. Satellites in geostationary orbit, crucial for telecommunications and weather forecasting, are in jeopardy as enhanced radiation from the SEPs causes widespread disruptions and failures. Closer to home, the ever-growing number of satellites in low Earth orbit face increased atmospheric drag and risk deorbiting as the atmosphere responds to the immense input of solar energy. Those protecting our national security must also contend with the implications of solar eruptions, which can disrupt communications, surveillance, and navigation systems vital for operations. In our interconnected world, misinformation spreads like wildfire, amplifying panic and confusion during times of crisis. As Earth's magnetosphere reacts to the direct hit, substorms create breathtaking auroras that dance across the sky, while city skylines plunge into darkness as power grids falter. With cell towers down and navigation systems offline, bustling cities grind to a halt, gridlocked by traffic and cut off from vital communications. Are we prepared?
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Well, we all might be living longer these days, but the gap between our health span, that is, the number of days lived in good health, and our lifespan is also getting wider. A report in the journal of the American Medical Association has found that this gap has widened globally over the past 2 decades, now extending to some 9.6 years. In other words, you may live into your 90s nowadays, but that last decade probably won't be a lot of fun. And some places are worse than others. For example, in Australia, the health gap was 12.1 years, and in New Zealand, 11.8 years. That puts both nations on the top of the leaderboard, only being beaten by the United States, which is a lifespan-health span gap of 12.4 years. And the health span-lifespan gap was also 2.4 years wider in women than in men. The researchers say the findings are suggesting that this health span-lifespan gap is a universal threat to healthy, happy longevity. It also means that the last few years of your life are likely to be pretty lousy. Google has announced its new quantum error correction chip makes corrections with a success rate above the threshold needed to function. Quantum computers are seen as the way of the future, but they're prone to errors, and that makes their current technology impractical. Quantum researchers have been working on ways to correct those errors without introducing new, more errors that they can't fix. Google says the newest generation of their new superconducting quantum processing chip architecture, known as Willow, can correct errors below the threshold. A report in the journal Nature claims that when tested for several hours, Willow was able to maintain its performance, suggesting a light at the end of the tunnel. Scientists with the University of New South Wales have successfully developed an organic material that's able to store protons and used it to create a rechargeable proton battery. By leveraging hydrogen ions, that is protons, instead of traditional lithium, these batteries hold promise for addressing some of the critical challenges in modern energy storage, including resource scarcity, environmental impact, safety and costs. The discovery, reported in the journal Angewandte Chemie, highlights the battery's ability to store energy quickly, last longer, and perform well under sub-zero conditions. The material has been shown to support rapid proton movement using hydrogen bond networks. Batteries store chemical energy and then convert it to electrical energy through reactions between two separate electrodes, the anode and the cathode. And charge-carrying particles known as ions are transferred between the two by way of an electrolyte. Now, the most common type of batteries used in household products nowadays are lithium-ion batteries, which create an electrical charge by transferring lithium ions between the anode and the cathode. Lithium-ion batteries power everyday products such as mobile phones, laptops and smart wearables, as well as newer e-mobility products such as electric cars, e-bikes and e-scooters. But they're highly unstable, especially when affected by damp, often causing fires. And they're both very difficult to produce, requiring huge amounts of water and energy, and difficult to recycle. On the other hand, protons have the smallest ionic radius and mass of all elements. That allows them to diffuse quickly. Using protons results in batteries with high energy and power density, plus protons are relatively inexpensive, produce zero carbon emissions, and are fast charging. Apple have just released the new 18.2 AI just in time for Christmas. And not wanting to be left out, Google have also launched a new beta version of their new Gemini 2.0 AI. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.live.
Yes, now this is where Apple Intelligence was launched into more places than just the US. With 18.1, you could access Apple Intelligence and create Genmojis, which is your own little creations of emojis just by describing them, and a few other things, but it was US English only. And I actually changed my phone to US English, but then, of course, whenever I was typing things, it kept wanting to Americanize the spellings. So now, with 18.2, Apple Intelligence is available in Australia and the US, in Canada, Ireland, South Africa, the UK, and the US. And we'll see more European countries next year. We'll see a smarter Siri 2.0 in April of next year. But with this launch, ChatGPT was integrated. So even if you're not paying for ChatGPT, you can get results and responses from ChatGPT beyond Siri's capabilities as yet. And in fact, if you have one of the new iPhone 16s with the camera button, you can hold it in front of anything and then tap Ask, and it will ask ChatGPT to describe what it sees. Now, you can do this with Google Lens free of charge on any iPhone or Android device. Even if it's older, you just download the Google Lens app, or the Google app really as it is. There's a little camera button in the search bar. You can tap on that. It'll take a picture and give you a description. But this is a nice little built-in thing into Apple. Apple's trying to catch up as much as it can, and it's got the text generation, the writing tools, the image generation. Not photorealistic images. Apple is very careful. They don't want to have photorealistic images that could be misconstrued, and you've got to go to Grok for that if you want that sort of thing. But Apple managed to launch a suite of AI tools just in time for Christmas to make all those iPhone 16 models work really beautifully with some of the things that were promised at WWDC. And then Google has also launched on the same day Gemini 2.0. Now, it's just in effectively a beta version, but this is Gemini 2 Flash. This is the version that is for developers, and you can also use it on your Android device if you've got the Gemini app downloaded and installed and you're using that instead of Google Assistant. And this is where it's multimodal, so it can accept images and sound and can read text, and it can generate images and sound for you. It's supposed to be faster, twice as fast as the previous model. And they're also trying to bring forth the agentic era where your phone or computer will start doing things for you because you've asked it. It'll be able to see what's on your browser or access the keyboard and mouse and do things for you. Like in Star Trek where they said, okay, computer, do this, do that. The computer then does it. It's always been science fiction, but it's now starting to happen for real. So we've got a lot of cool things happening in the past few days in the world of AI.
That's Alex Zaharov-Reutt from TechAdvice.live. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.